In today's class, we are going to look at some more graphs. In the last class, we discussed the identity function, the constant function, x power 2 x squared x cubed. Today, we'll discuss rational functions. So in rational functions, the first type of function is where we have a y equals to 1 by x to the power odd. So x to the power 1 or x to the power 3. Or we can also say this as f of x equals to 1 by x, as it is a function of x. So let's see how the graph comes out in this case. Say we put x equals to 1. So when we put x as 1, so f of 1 is equals to 1 by 1, that is 1. If you put x as 2, so f of 2 is 1 by 2. So at 2, the value is half. At x equals to 3, we get 1 by 3, that is 0.33. That is further smaller. And if you put 4, then 1 by 4, we get 0.25. So this value is keeping on decreasing. And if we take a value below 1, say if we take half, so f of half will become 1 divided by half. 1 divided by half, 2 will go to the numerator, it becomes 2. So f of half is 2. So if I take 1 by 3, for 1 by 3 I get 1 by 1 by 3, which will become 3. So f of 1 by 3 is 3. F of 1 by 4 similarly 0.25 will become 4. So as we are proceeding towards 0, the value is continuously increasing. So what happens is we get a graph somewhat like this. Here, this value keeps on decreasing, but it never becomes negative. How much ever big the value of x you take, say you take 1000. So 1 by 1000 becomes 0.001. So this value keeps on decreasing, but it never becomes negative. And however close you take near to 0, say we take x as 0.0001. So 1 by 0.0001 will become 10,000. So if we take very close value to 0, the higher the value becomes. And for the negative part, if you take f of minus 1, that is 1 by minus 1, whose value is minus 1. F of minus 2 is 1 by minus 2, that is minus half. Minus 3. So it keeps on decreasing here also, and as we go towards 0, say minus 0.5 or minus half, f of minus half is 1 by minus half, which becomes minus 2. So what is happening is this is decreasing over here, is trying to reach 0, and as we are going towards 0 from the negative side, this value is continuously increasing. So this value is continuously decreasing and going towards minus infinity. See, why do we say 1 by 0 is undefined is because, see, at x equals to 0, from the left side it is going towards minus infinity. From the right side is going to plus infinity. So we can neither take minus infinity nor we can take plus infinity. That is why we say that 1 by 0 is undefined. Okay, so here domain we get is the set of real numbers minus the set 0. We are not taking 0 because at 0 the function is not defined. So wherever the function is not defined, we can't take those values. So domain becomes r minus 0. At 0 it is going from the right side, as we going towards 0 it's going to plus infinity. From the left side this is coming towards minus infinity. So we cannot say any value at 0, hence domain is real numbers minus 0. We do not take 0 over here. Now the range. So it's starting from plus infinity going towards 0. So plus infinity to 0. So how much ever big the value we take, say we take 1 crore. So 1 divided by 1 crore, it's still a positive quantity. We do not reach 0 howsoever big x value we take. So it's going from 0 to infinity. It's starting from 0, it's going to infinity, and here it's starting from 0, it's not reaching 0 and going till minus infinity. So minus infinity to 0 union 0 to infinity. Starting from minus infinity, it's coming till 0, but the value 0 is not attained. Again, it's starting from a little positive number, it's not starting from 0. 0 is not attained, so we are putting a open bracket in front of 0. And as we are going, what happens is this is increasing. So it reaches till infinity, starting from minus infinity till 0, union 0 to infinity. But 0 is not included in both the cases. Or for the range, we can also write, see, this is from minus infinity to plus infinity. The only point 0 is excluded. So we can write this as r minus the point 0. This is also fine. You can write range as this value as well, or you can write as this value as well. Both of them denote the same thing. Okay. After range, we have, like in the last portion we did what f of minus x was and symmetric functions. So over here we see f of minus x is a 1 by minus x, which is equals to minus 1 by x, that is minus f of x. So this implies f of minus x equals to minus f of x, hence it is an odd function. And the fourth point is that whenever we have an odd function, so it is always symmetric about origin. And we can see from the graph itself, it is symmetric about origin. See, symmetric about origin. The second one in the rational functions, we have y equals to 1 by x square, or f of x equals to 1 by x square. Now, what is the basic difference between this and this is that whenever we have power even, the negative values that we put also becomes positive. So this is the difference between 1 by x or 1 by x cube, 1 by x to the power 5 whenever we have odd powers of x, and 1 by x to power even. So let's plot the graph. Okay, so you put x as 1, so 1 by 1 square is 1. We put x as 2, so 1 by 2 square, that is 1 by 4. So we get a 2 value 1 by 4. So if you put 3, then we get 1 by 9. If you put 4, 1 by 16, the value is keeping on decreasing, but it is not touching the x-axis. This is keeping on decreasing, but it does not touch the x-axis. And if we take a value towards 0, say 1 by 2, half we take. So 1 by half square is 1 by half square will become 1 by 4, that is equals to 4. So the smaller the value we take from 1 towards 0, the greater the value it tends to. So 1 by 3 will become 9. So what happens is this is increasing. Comes to 1. Then as we are moving towards the right, it is decreasing. As we are moving towards the left, it is increasing. So this is the graph for 1 by x square. And on the negative side, as we see, if you put -1, so -1 square is 1, -2, so 1 by -2 square is 1 by 4, because negative square is positive. So here also what is happening is values continuously decreasing. And as we go towards 0, say 1 by -half square. So -half square is also 1 by 4. That becomes 4. So -half, we get value 4. If we take this, then 9, 1 by 3. So this value is again over here in this way. So the type of graph that we are getting over here is that, see, again at 0, left hand side it is going towards infinity, right hand side it is going towards infinity, but at what point they will meet we cannot say exactly. So here also when we write domain, what we do is we take the whole real number other than 0, because in 0 it is going to infinity from both the sides. So infinity is not a real number, infinity is just a concept. So that is why the domain is r minus 0. Second part, range. If we see the range, what is happening is the minimum value that is going over here is 0. It's not touching 0 exactly, but it's starting from 0 excluding 0 and is going till infinity. So this is from 0 to infinity. Or we can also say this as R positive, meaning the positive real numbers. In the set of positive real numbers, 0 is not included because 0 is neither positive nor negative. Third part, f of minus x equals to 1 by minus x whole square, which is equals to 1 by x square, which is equals to f of x itself. So this implies this is an even function, and this will be symmetric about a y-axis. Whenever we have even function, it is always symmetric about a y-axis. So these are our rational functions. The third rational function is f of x equals to, the third one is over here, f of x equals to root x. Whenever we have a root, what happens is over here we cannot have root under of negative number. So first of all we'll write the domain. So here a domain, when we write, since inside root we cannot have negative, x is greater than or equals to 0. So it can be 0 or it must be greater than 0. So domain will be from 0 to infinity including 0. So how will we plot the graph? So root of 1 is 1, root 2 1.414, root 4 is 2, root of 9 is now 3. So we get a graph something like this. So root of 0 is 0. So this is increasing continuously, but this is not increasing like it was initially. From 0 to 1 it was almost like a straight line. From 1 to 2 when it was going, so this has a gap of 3 over here. So the value is increasing but at a decreasing rate. So the value is increasing over here. So here we cannot take f of minus x because root under of negative is not possible. So we do not write this as even or odd. So second, for a range, this is starting from 0 and this is continuously increasing. So this will go from 0 to infinity. And third point, this is a neither odd nor even. Okay, let's talk about what infinity is. Okay, infinity is just a concept and not a real number. We do not take this as a real number. It means a value bigger than the biggest. Okay, so the biggest value I can think of is say 1 arab. So next value bigger than 1 arab, that is 1 arab and say 1000. So that will be infinity. So if I now think about 1 arab 1000, the value bigger than that is infinity. So infinity does not stop. Whatever biggest value we think, a value bigger than that is infinity. So that is why we cannot take infinity as a number, because it does not stop anywhere. Infinity is just a concept and not a real number. So we never include infinity. We always write infinity in open bracket. Okay. Fourth one is the exponential graph. Or exponential function, where f of x equals to a to the power x. Let's take an example of f of x equals to 2 to the power x. So x equals to 1, what happens is f of 1 equals to 2, at x equals to 2, f of 2 is 2 square 4, at x equals to 3, f of 3 is 2 to the power 3, that is 8, at x equals to 4, f of 4 is 2 to the power 4, which is 16. And for negative value, f of, say, at x equals to minus 1, f of minus 1 equals to 2 to the power minus 1, that is half. At x equals to minus 2, f of minus 2 equals to 2 to the power minus 2, that is 1 by 4. So the value never becomes negative. It's keeping on decreasing with decreasing value of x, but it never becomes 0. So we get a graph like this. So with increasing values of x, what is happening is the value is increasing. At 0, if we take x as 0, any value to the power 0 will become 1. So at x0, the value is 1. At 1, say 2. At 2, 4. At 3, 8. So what is happening is this is increasing in this way. And over here, if we take minus 1, then minus half. Minus 1 by 4, minus 1 by 8, minus 1 by 16. So this value is continuously decreasing. This starts near about 0, not exactly at 0, because if we take how much ever smaller value, this will still be greater than 0. If we take x as minus 1000, so 2 to the power say minus 1000 will be 1 by 2 to the power 1000. That is still a positive quantity. So this will always remain positive, never touch this axis. but still it will continuously move towards 0. So over here, first of all, domain, you can put the value of x, anything over here, any real number. So domain is the set of real numbers. Second, range. Range, you're getting from 0 to infinity excluding 0. So this you can write as r positive, or you can also write as 0 to infinity excluding 0 and infinity. Here again f of minus x is completely different thing. So this is neither even nor odd. Next graph. Now fifth graph for today is the logarithmic function. So where f of x equals to log x. So log of negative is not defined. So over here, domain, first of all, we'll write this as r positive. F of 0 is also not defined. So domain is from r positive. See, bases can be different bases over here. So let's say I have base 2, say log 2 base x. We are just taking an example. So at x equals to 2, log 2 base 2 equals to 1. At x equals to 4, log 4 base 2 equals to 2. At x equals to 8, log 8 base 2 equals to 3. So what is happening? What this graph will look like is 1, 2, 3, 4, 5, 6, 7, 8, 9. X prime, y prime. So say at x equals to minus 2, log with base 2 minus 2 is not defined. So this is not defined. See, at x equals to 1 by 4, log 2 1 by 4 equals to basically log base 2 to the power minus 2, that is minus 2. So we are getting with values less than 1, we are getting negative. So at 1 by 2 we'll get minus 1, 1 by 4 will get minus 2, 1 by 8 will get minus 3. This log, base be anything, a log of 1 is always 0. Log 2 is 1, log 4 is 2, log 8 is 3. So the logarithmic graph looks like this. For students of CBSE, you are not very much familiar with logarithmic function, log. So we'll also have a dedicated class only for understanding what logarithm is, because logarithm becomes very essential part of your problems in coming chapters. So domain is R positive. Range, it's starting from minus infinity going till plus infinity. So the range is real numbers. So this is also neither odd nor even, because there is no reflection over here, and log of a negative number is not defined at all. So that is why our domain is R positive and range is R.